My name's Grant Hulegaard, and I'm going to be talking about how to analyze NGINX configs. So hopefully that talk sounds familiar. If not, you're probably looking for a slightly different room. A little bit about me to start. I've been a software engineer for about 5 years. I've done back end, I've done front end, and just about everything in between, including PagerDuty and ops work. For the last 3 years, I've been at NGINX, and I started work on NGINX Amplify, which is a monitoring and analytics service for both open source NGINX and NGINX Plus. Now, though, I am working on NGINX Controller, which is basically monitoring analytics as well as configuration management. So during this talk, we're going to do a couple things. The first is we're going to ask the question and hopefully answer, why should I analyze my NGINX configs? We're going to talk about how to parse NGINX configs. We're going to go through a couple examples, and at the end, we'll do a little wrap-up and some questions. So first, why should I analyze my configs? The problem. NGINX is a high-performance and feature-rich web server, load balancer, reverse proxy, cache. So it's not just any one thing, and it does a whole bunch of things. And if you're like me, you're probably using NGINX in multiple ways, even in the same app deployment. Because of this, NGINX configs also have to be powerful and complex to be able to express all these different conditions of which you want to use NGINX. And if you really think about it, powerful and complex is just a nice way of saying complicated. So if you go to NGINX.org today, you will find documentation on 85 different modules, 214 directives, and 208 different variables in the configuration file. But there's even more. You can have conditional statements with if. You can have goto statements or goto statements with rewrite, case statements using map and geo, and you can have inheritance. And I have inheritance highlighted here because let's talk about that for a minute. If you have this simple NGINX config, as you can see, there's a single server. It has 2 locations. In the server block, there's an add header, which adds a request ID, so a unique identifier for every request coming into the server. And then in location /, it just returns 200 index. But in location other, we add an additional header, cache control, which has the value no cache, always. So if we fire a request to /, we would expect something like this. It's a HTTP header, standard HTTP headers with a 200 response code with the string index. And we'll see our request ID right in the bottom of the headers. If we were to fire a requested /other, we'd expect to see the same thing with the string other and an additional cache control header. But actually, if we were to run this request, we wouldn't see the request ID header. The reason for this is because NGINX treats inheritance as a inherit if there's nothing else. So what actually happens in this config on the left is when you write the add header cache control, you actually overwrite all the headers that were added before. So X request ID doesn't show up in other. Another thing that you might want to check for when analyzing configs is best practices. So if you use NGINX as a reverse proxy, you've probably seen something similar to this. A single location with a proxy pass and an include headers file. And if you were to open up that headers file, you'd probably see something similar to this, a whole bunch of proxy set headers with header values and variables. This is actually best practice. So in an ideal scenario, for every proxy pass, you will have at least this number of headers with these values in every proxy pass scenario. But you also can have bad practices. So in this server configuration, it's pretty similar to the one previous, but in proxy pass, we actually have a proxy pass using a variable HTTP host. So as a really quick review, $host as a variable is in this order of precedence: host name from the request line, host name from the host request header, or finally the server name that you have configured in NGINX. That means that the first 2 things that host can be is actually can be somewhat influenced by the incoming client. $HTTP host is just the host header from the HTTP headers. And actually, you can access any header in your request at runtime with NGINX configs using $HTTP underbar, where name in this case is your header name converted to all lowercase, replacing dashes with underbars. So if we wanted to access X request ID from previously, we could do $HTTP underbar lowercase x underbar lowercase request lowercase ID, and that would give us that header value. This is actually bad practice because earlier this year, some security researchers discovered that if you're deployed in a cloud environment, you can actually have outside resources or internal resources be exposed, specifically instance metadata APIs. So instance metadata APIs are things for cloud providers in EC2 or Azure or GCP that provide metadata about your underlying virtual server, what instance type it is, where it is, stuff like this. They're sensitive information, but they're highly useful for automation or sort of inspection. These are things that you don't want exposed to the internet, and so most cloud providers by default restrict it to only virtual servers on your virtual private network. So in this example that they give in their blog post, they actually can fire a request from their local machine into the cloud through a reverse proxy of NGINX and access this instance metadata API, all because this proxy pass is using HTTP host as the variable rather than directly in. So when the host that has the instance metadata API is evaluating whether or not it should allow you to access that materials, it thinks it's talking to another local host machine, in this case, your NGINX reverse proxy. And the blog link is there. So hopefully by now, you're starting to see how NGINX configs are very complex and complicated and may have things you want to check for. But you don't have to take my word for it. There's lots of community members and projects on GitHub that actually do similar things to check for certain errors and give you certain reports on your NGINX configs. But before we analyze NGINX configs, we have to be able to parse NGINX configs. And so the key word here is understand and parse. So a little definition from the internet. Parse, in linguistics, is to divide language into small components that can be analyzed. So it sounds roughly what we want to do. We want to divide an NGINX config into small components, which we then can use that structure to analyze. Link to the definition I used. So before we get too far forward, a brief history of Amplify and how we did config parsing. So the first thing to know is that NGINX itself does not have a config parser. There's not a moment where NGINX takes an entire config and reads it all at once. That sounds a little bit odd, but if you think about it, it makes a lot of sense. NGINX is an asynchronous, high-performance asynchronous event engine, and it has lots of different modules. Each module is going to have a subset of the config and directives which affect its behavior, so it makes sense that NGINX will bootstrap itself, and then as it bootstraps the modules, those modules will read the parts of the config that it's interested in and nothing else. But because NGINX doesn't have a config parser when we were creating Amplify and Controller, we actually do need to read the entire config, so we had to do it ourselves. So like good Python programmers, the first thing we did was to see if somebody else had done it already. What we found was a variety of tools, but particularly one stood out to us that inspired us to do a similar thing, and the link is here. And what it does is basically use a library called PyParsing to find keywords and regular expression rules for capturing structured data out of text. And PyParsing, we took their initial implementation and we extended it. And eventually we got something that fit our needs, or at least so we thought at the time. What we found was that it was slow and was susceptible to edge cases. So as we had more and more users start using Amplify and Controller, we would find new configs that had new settings that we hadn't considered before or had different formatting that we needed to improve our rules for. And so we'd go a month with no errors. We'd have a new one. We'd fix it. We'd have a new one. We'd fix it. But one of the problems with parsing with regular expression rules is as you get more and more complex with your regular expression rules, it gets really, really difficult to consider all edge cases because there's a lot of overlap potentially between your rules. You can't be parsing one block and then accidentally capture characters that are important for another. But the first biggest problem was performance. Luckily for us, the author of PyParsing, Paul McGuire, actually reached out to us because he realized that, or found out that we were using PyParsing and offered to help us optimize our utilization of PyParsing. So without changing the logical structure, he improved our calls into his underlying library, which resulted in 59% performance improvement. And to that, we're eternally grateful, and it really saved our bacon. But even after that performance improvement, it was still pretty expensive. It's something we didn't want to do all the time. Users with really large configs, probably some users in this room, will have hundreds or thousands of files even, and that takes a lot of time to go through and run regular expression parsing on each and every file. And of course, even though it's faster, it's still susceptible to edge cases. It's still regular expression based. If you're interested in seeing that original implementation of the parser, there's a link here that points back to the open source agent and an earlier point in time before we moved on to crossplane. Which brings us to crossplane. And I can't talk about crossplane without introducing this handsome gentleman on the left. This is Ari van Lutikhuizen, and this is being recorded. So Ari, if I pronounced it wrong, I'm really sorry. He spent a whole day trying to get me to do it right. So hopefully I did it right. But Ari is a coworker of mine. And about a year after constantly every month or so fixing a new edge case that we'd find, he threw up his hands and said, I bet there's a better way to do this. So again, like good Python programmers, we revisited and see if anybody had done it better already. But we find out that not much has changed. The same libraries and the same tools that we found before are essentially the same. And they not one specific tool covered all the edge cases we needed. So now that we've been running Amplify and Controller for about 2.5 years, we've collected a lot of regression tests and edge cases and user configs that expose these bugs. So running these tools over those configs never actually met all of our use cases. So he decides to write his own, and he wants to take an NGINX config and convert it to JSON and back. But for the purpose of parsing, we're only interested in going to JSON. And he does it, and he makes good on his promise. It's faster and much more reliable. In the 6 to 8 months that we've been using it in our agent, we've only found one thing that we've actually had to fix, which is drastically better. I can't express how much better it is for us as developers to not constantly be reopening parsing bugs. He even went a step further, and rather than just parse an NGINX config file, he uses NGINX directive definitions to do a little bit of validation, so making sure that your directives are in different blocks. We'll talk about that in a little bit. But crossplane is an open source project. It's available on the NGINX GitHub. It has good documentation, and you can use it today for yourself. And there's a link there. So NGINX directive definitions. If you've just been starting out with NGINX, and you're like me, you probably use NGINX-T a lot. And you usually find some problem in your config. And you get a message something like, emerge log format directive is not allowed here in this file line number. What that's saying is that my log format is in the wrong context, right? So it should be in the HTTP block, but I accidentally put it in the location block, or I put it somewhere it wasn't expecting. So if you use crossplane, you will see that error in a crossplane format, but also through the UI of controller, also in your analysis here. There you go. So let's take an example of config and turn it into crossplane and analyze the structure. So this is a simple configuration file. I've called it simple.conf. It has an events block. It has an HTTP block, one server listening on 127.0.0.1, 80.80, server name, default server, so on and so forth. This is actually a perfectly valid NGINX config. You can take this config and run it on NGINX, and it will work exactly as you expect. If we were to run it through crossplane, we'd get a structure, or at least a beginning structure, that looks somewhat like this. Right? So at first here, we can see at the top that there's an overall status and errors page. So in this case, there's no errors. Status is OK, therefore. And there's no errors in the errors array. If we did have errors, there would be messages in that array for however many errors we had. Config is an array of all the different files. So crossplane will analyze each file or turn each file individually into JSON. And each file also has its own status and its own errors. But the first information we can get that's from the file itself is actually the file name, which is available as simple.conf. And then if we go to parsed, we start going through each directive and their subblocks. So this directive events in this JSON structure corresponds to events here. The block array here corresponds to the open and closed parens of the events block. And the JSON within the events, or the block JSON area, corresponds to each directive. So we have worker connections, and we can see it here. And we have arguments 1024, which is the arguments 1024 here. So now you're sort of starting to see a structure which is repeatable, and you could recurse all the way through. And so if we expand that out, you'd see something like this. But there are some notable things that I want to say about the follow-up that makes sense. So without going through everything, you can see HTTP and server. But the listen argument here has some formatting white space. Right? So when NGINX reads this, the white space is ignored, and 127.0.0.1, 8080, is what is being referenced by the first argument for NGINX. Likewise, the white space is stripped by crossplane here, so you don't have to worry about formatting white space when doing your analysis. Also, as an example, the return below actually has multiple arguments, right? So it has a 200 status as well as a string foobar baz to return. And those arguments also appear as different elements in the array if you have multiple arguments. And so that's really it for crossplane. So some examples. Let's revisit that inheritance example that we had. If we were going to take this into crossplane, we would get something like this that's interesting. The ellipses are just going over parts of crossplane that are included, but we're not interested in for the purpose of this analysis. But very clearly, you can see the add header here, there. And then the sub location other is also here. And in its block, it has an add header. So if we were thinking about how to analyze this, we could come up with some steps, right? First, we could initialize a flag as false. And then as we step through the tree for crossplane, every time we see an add header, we can consult the flag. If the flag is false, we can flip it to true. And the next time we see add header, if it's already true, we know we've seen it before. Therefore, we're overriding the context of add header. So that would look like this. Initialize as false. We go through the structure, find the first add header. We would see true. So we see it's false, flip it to true. But the next time we see add header, we see that it's already true. And so we know to raise a warning. And so that's how you can sort of catch the inheritance. This also applies to best practices. Best practice is a little bit more complicated, and it's sort of hard to fit it all into one slide, so we're just going to talk this one through. But proxy set headers has the same inheritance parameters as add headers. So what you want to do is initialize a context. Every time you find a proxy set header, you should override the previous context to be just the context of the current level that you're at. So if you have a server context, if you have another context and location, rather than adding to it, you need to first override it. But basically, every time you find proxy set header, you add it to this context. And then whenever you find proxy pass, you can then consult the context to see what the value of those proxy set headers are when that proxy pass is evaluated by NGINX. And in that way, you can confirm that every proxy pass in your config is referring to a set of proxy set headers that makes sense at runtime. We can also do bad practices. In this case, we're only interested in the directive proxy pass and its first argument. And so in crossplane, it would be right there. So the first thing to do is we just look for all proxy pass directives, and we examine it. I have one caveat, which is we only want to look at the first argument. And that's because we're interested in what server it's being proxied to, which is the first positional argument after proxy pass. And there's some other stuff that is explained here. I'm going to try to do a better job than explaining it how I explained it in the slides. But basically, the vulnerable proxy pass configurations are the ones that use $host or $HTTP host after your scheme. So the thing that's determining what server you're going to that can be user modified. So some examples at the bottom. We have scheme HTTP / $HTTP _host. We have $host/ with no scheme. And then we have a host proxy with passing an argument on a command as a URL argument, $HTTP host. So we can't just check to see if $host or $HTTP host are in the string. We actually need to check the position to determine whether or not it's vulnerable. But in this example, the first two are vulnerable, and the last one is not. So at this point, we've gone over why you would want to analyze configs, some examples. We've shown you crossplane, which will take an NGINX config converted JSON for you, and you can write your own analysis. But we also have a lot of analysis in NGINX Controller, and by extension, as well as Amplify. So a list of, at the time of this talk, these are all the static analysis reports we have in Controller. The ones we've talked about in these examples so far are highlighted in bold. Proxy pass headers is the best practices. Insecure proxy pass is the bad practices. And header inheritance overlap is inheritance for add header. And these are all just the reports for analyzing your configs without any knowledge of what server you're running on or what NGINX version you're running. But if we think about the agent being a sidecar service, we also have information about that stuff. So we can do additional stuff. We can give you a configuration overview, so you can see how many listens you have, what ports are being bound by NGINX, how many are using SSL, how many are not. We can raise warnings for you when your SSL certificates are about to expire, and only the SSL certificates that you are using. We can also match your certificate info to where they're being used in your config. So certificates have domain names that they apply to. We can make sure that the certificate you're using in your server block matches your server name definitions in NGINX. And we also can give you security advisories. So because we know what version of NGINX you are, we can go check if there's any security advisory that affects your version. And we can also tell you which version to upgrade to no longer be affected by it. So a live example. So I have a demo machine set up, and hopefully everything goes well. But it's running this configuration. It has an events with the worker connections. It has an HTTP block. It has an extended log format. If you're using Amplify or Controller, this is sort of the log format you would be using to get all the metrics. It has an access log and error log defined. And it has a single server with an add header in the server block, a location with a proxy pass, and a location stub status. If you're not familiar with stub status is a module in open source NGINX that exposes a JSON payload with some metrics for your global runtime. And let's see if I can do this right. This is the Amplify demo account that I've set up with this server. So on the left here, sandbox conf gsh is the name of my server. It's running NGINX plus R16. And if you go over to Analyzer, we can see what the Analyzer will say about this config. So on the left, it shows us just overview information of the status. It's up. It has security advisories. There are none because we're using the latest NGINX Plus or a non-vulnerable NGINX Plus version. It has no SSL being used, so there's no SSL warnings. And the virtual servers over here just tell us that there's one server with one listen IP port combination. And if we drilled down into that, it'd show you what IP port combination it is and what configuration line it appears on. But this is the static analysis area, and this is sort of where the warnings that we've talked about today would appear. And it appears that our analyzer has caught one error and two warnings in one file with two locations. So if we open that up, we can see all the errors and the warnings that occur. So the first is missing server name in the virtual server configuration. So we didn't define a server name. We're also missing proxy pass headers. So if you paid close attention to the previous slide, you would have noticed that I just had proxy pass with no include and no proxy set headers. So this is warning us and telling us that we should add these headers. But we have one error, and that's missing ACL for stub status, which is something we haven't talked about. But stub status is sort of an overall statistics for your runtime. And so it's best practice to always put access control on it. And so access control is usually best as allow localhost only and deny everything else. And there's an example provided. And so that's the analyzer in a nutshell. And this is actually an Amplify. So you can create an account today and run the analyzer through Amplify on your configs if you'd like to try it. And you can also get this as part of Controller. Play from that slide. So just in case that didn't work, I had some slides with some pictures. But it did work, so we're good. So wrap up. So we've talked about why you'd want to analyze configs. We've given 3 examples. We've talked about parsing configs with crossplane, which is an open source library that you can use today and is available on our GitHub. And we've walked through some example analysis as far as what you can do today on your own. We've also talked a lot about all the reports, including the ones that we talked about today, that are available in Controller. And we've done a quick walkthrough of the live example. And that's really all I had to talk about. So we've got a bit of time. Are there any questions for me? No. Oh. So.
Since NGINX can be used so many different ways, like I said, and if you're not using it in this way, it doesn't necessarily need to be configured, but if you're using it in this other way, it does. So is it doing dependency checks for, hey, it looks like this guy's trying to use this is a web server. If he doesn't have this required parameter, it's a problem. But of course, if it wasn't being used as a web server, it wouldn't be a problem. Is that level of check being done by these analyzers?
Okay, so the question for the video is about whether or not the analyzer has any smarts about how you're using NGINX based on your configuration. So if you're using it as a web server, your checks might be different from if you're using it as a cache. And so the answer is kind of, right? So most of the checks that we have involved revolve around how NGINX directives work within and affect themselves. So if you're using those directives, those warnings apply to you, right? So if you're not using proxy set headers, or proxy paths rather, you won't see any proxy set header warnings, right? Because they affect one another. So in a way, that's sort of smarts. We do have some reports which do some smarter checking, but I'd have to drill down into it. If you're interested, please stop by the booth, and I'd love to walk through it with you. Any other questions? So the question is whether or not you can define your own rules to add to the static analyzer running. Currently, no. However, I love that idea. I'd love to talk about that with you, and I'd love to put that on the roadmap if we can. Any other questions? Right, so the question is about SSL alerts and expirations, and whether or not you can set up alerts to warn you if your SSL certificates are going to be expired. So the answer is no, right now. We do show a warning for a month or so, or maybe longer, before your certificate expires in the reporting page. And we have talked about adding a email to you when you hit that warning, but it's not in the product currently. Any other questions?
Basic, but when you say it doesn't do parsing generally unless you're doing it through controller, what's happening when your file is being checked or like an
So the question is talking about parsing in NGINX and whether I meant by NGINX does not have a config parser concept. So what I mean by that is NGINX itself doesn't have a single parsing entity which parses the entire config all at once. Rather, each module, as it's instantiated during Bootstrap, will consult the config for the parts that affect it and ignore everything else. So each module will consult the config and only the parts that affect it, rather than what an agent needs, which is parse the whole config at once, right? NGINX, as modules come up, will look at each individual part of the config one at a time. Yeah, so NGINX will run through that Bootstrap process and then come out and show you errors. Any other questions?
While working on this, did you gain any other insights or thoughts about other ways to format the configs or to make them more self-documenting or to help with change control?
Yeah, so the question is, that's a great question actually, is in working on Config Analyzer if I gained any new insights about how I would format like my own configs. And so the answer is yes. There's a lot of things off the top of my head that I would talk about is using include smartly. You can avoid or offhead a lot of inheritance problems by putting all of your blocks of proxy set headers into a single file and just including it everywhere so you're not accidentally stepping on one another. Multiple files for change control is also helpful if you have different groups that have different sections of the NGINX config they're supposed to talk to. So I would say that best practices are, yeah, I mean, I don't have any other examples that are probably profound, but just sort of things that if you've been running NGINX for a while, you're probably naturally doing yourself. But yeah. Any other questions? Yeah, so apparently, whoops, sorry. Apparently I missed a question about versioning. So yes, controller does not currently today have a version history, right? So we know what version of config you're running. You can edit that config and you can push it, and we will track those changes for you. But we don't visualize to you what your previous changes were. in a future roadmap, very soon actually, I believe, we should have version history. So for every config that you have, we can track all your changes, whether or not you've made those changes through the configurator UI. So if you've made changes on your server outside of NGINX configurator, we can still track those changes for you. Any other questions? No. Well, thank you all for coming, and if you have any other questions, feel free to find me out at the booth.